We have here the integral of the square root of e to the 3x plus 6 e to the 2x all over e to the 2x plus 14 e to the x plus 49 dx. Okay, right away, there's a lot of things that are jumping out here to me. Like, first of all, in the numerator, I'm thinking we could probably factor out an e to the 2x here. And then in the denominator, I noticed that that's actually a perfect square and we're inside the radical. So I think that's going to be useful right there. So I think I'll use those two things. And first we will factor out an e to the 2x here. And then so if I do that, I'll write this as e to the x plus 6 in the numerator. And then writing this as a perfect square, this is actually going to be e to the x plus 7. That's all squared, and this whole thing's under the radical. But now e to the 2x, that's the same thing actually as e to the x squared, and that's in the radical. So that means we can take the square root of this, and we can take the square root of this denominator. That's going to allow me to pull this e to the x out from the numerator, and then we're going to have square root of just e to the x plus 6. And then the denominator, because we're squaring this and we're inside the radical, this is just going to be e to the x plus 7 dx. And then from here, I think what I want to do is a u substitution. I think initially on paper I did my u substitution just for this piece, but I think if we include the radical, it's going to actually work a little bit better. So let's see how that's going to go. I'm going to say u equals square root of e to the x plus 6. I think I want to get a value for e to the x, and it's going to help me take my derivative. We could just do it right now, but I think it's going to work out a little nicer. So if I square both sides, we'll have u squared equals e to the x plus 6. And then solving for x, we have e to the x equals u squared minus 6. And then I'll take a derivative. So we're going to have e to the x dx equals, derivative over here is going to be just 2u du. If I move my e to the x to the end and we group it with dx, we have this 2u du. So what I'm going to do is make this substitution right now. This value here is just u, so we're going to have u in the numerator. Again, this e to the x dx is going to be times 2u du. So in the denominator, substituting in for e to the x, we're going to have u squared minus 6 plus 7. That's going to give me u squared plus 1. And then from here, what I'm going to do, I'm just going to take this 2. Let's bring that up front. We'll multiply u times u and get a u squared. But let me just clean this up so it looks right. Okay, so now we're just integrating u squared over u squared plus 1. I think what I'm going to do to finish this off is let's just add a 1 so that now this is 1. But I don't want to change it, so I'll subtract 1. And then let's take this minus 1 and split this off into a separate integral. So I'm going to write this, we're going to have to distribute in our 2. So I'm going to write this as a minus 2 in front, and I'm just going to write it as du over u squared plus 1. But then again, this is going to cancel the 1, and so I'm ready to integrate. So here, integrating 1, we're just going to have 2u minus 2. So the integral of this is just going to be arctan of u. So we'll just back substitute with our u value here. And so for our final solution, we're going to have 2 square root of e to the x plus 6 minus 2. And then we'll just have our arctan of u, which is square root of e to the x plus 6 plus c. And that's it, we're done. Oh, this pen's kind of getting a little dry, I don't know. All right, so we'll stop it there. Thanks everyone for watching. Have a great day.